study the discovery of subatomic particles. Now, in this first, let's talk about the discovery of electrons. तो discovery of electrons कैसे हुई, उसके लिए J.J. Thomson was conducting some experiment using discharge tubes or the cathode ray tubes. Okay, now this is somewhere around the 19th century that this experiment is being conducted. And what did he do in this experiment? He actually took a cathode ray tube या एक डिस्चार्ज ट्यूब. डिस्चार्ज ट्यूब क्या होती है? इट इज बेसिकली अ ग्लास ट्यूब. अगर आप ध्यान से डायग्राम को देखें तो दिस इज अ ग्लास ट्यूब विच इज क्लोज्ड एट बोथ द एंड्स, राइट. और इस डिस्चार्ज ट्यूब में he connected two electrodes, एक cathode एक anode, and these cathode and anode in turn were connected across a battery. तो बेसिक सेटअप ये है कि देयर इज अ ग्लास ट्यूब व्हिच इज क्लोज्ड एट बोथ द एंड्स, two electrodes facing each other are connected inside it, and in turn it is connected across a battery. और नीचे अगर आप देखो तो नीचे एक वैक्यूम पंप लगा हुआ है. इस वैक्यूम पंप का पर्पस क्या है? टू एडजस्ट द प्रेशर, टू वेरी द प्रेशर इनसाइड द discharge tube. Correct. Now this discharge tube is filled with some gas under study, and these two electrodes we are supplying them with very high voltage. तो दो चीजों का ध्यान रखेंगे इसमें. एक चीज तो, पहली चीज तो क्या है कि हमने इन दोनों ही इलेक्ट्रोड्स के अक्रॉस क्या कनेक्ट किया है? वेरी हाई वोल्टेज. और दूसरी चीज कि गैस के अंदर डिस्चार्ज ट्यूब के अंदर जो प्रेशर है, that pressure is extremely low, very low pressure. Okay, now under ordinary conditions what do we know? That gases are poor conductors of electricity. लेकिन वहीं पर अगर हम if we apply certain or sufficient amount of high voltage across the electrodes at very low pressure, then we see that gases become conductors, and when gases become conductors we can see electricity begins to flow in the form of rays. तो अगर आप यहाँ देखें कैथोड की तरफ से there are rays which are being produced. Let's see more correctly in the second diagram, part B of the diagram. Okay, तो जब हमने बहुत हाई वोल्टेज कनेक्ट किया across the battery, then we saw that rays started coming out from the cathode. और ये रेज किधर को मूव कर रही हैं? एनोड की तरफ को. That is why we called them as cathode rays. अब इन रेज की कुछ प्रॉपर्टीज हैं. बेसिकली दे आर बीम ऑफ इलेक्ट्रॉन्स दैट आर मूविंग. ओके, सो फर्स्ट लेट्स टॉक अबाउट द प्रॉपर्टीज ऑफ दीज रेज. सो दीज आर कैथोड रेज. कैथोड रेज आर फास्ट मूविंग बीम ऑफ इलेक्ट्रॉन्स. बहुत इंपॉर्टेंट चीज, फास्ट मूविंग बीम ऑफ इलेक्ट्रॉन्स. नाउ लेट्स टॉक अबाउट देयर प्रॉपर्टीज. पहली प्रॉपर्टी क्या लिखी है कि दे आर नेगेटिवली चार्ज्ड नोन फ्रॉम देयर डिफ्लेक्शन इन एक्सटर्नल इलेक्ट्रिक और मैग्नेटिक फील्ड. सो दैट मीन्स इफ यू कनेक्ट, हमको कैसे पता चला कि दीज आर नेगेटिवली चार्ज? वी वर जस्ट दीज आर जस्ट अ बीम ऑफ रेज कमिंग आउट. तो इफ यू प्लेस एन electrically charged plate in their path, अगर दो प्लेट्स लगा दी जाएं such that one is positively charged, the other one is negatively charged, तो क्या देखा गया कि these rays were deflected, they were deflected towards the positively charged plate. और इसका मतलब क्या है कि उनका खुद का नेचर कैसा है? they are negatively charged because we know opposite charges attract each other, right? So because they are attracted towards the positively charged plate, we came to know that they are negatively charged particles which are coming out of the cathode. Now they start from the cathode and end at the anode. Then the third one, by changing the electrode material, that means if you change the material of the electrode, so you take some other metal to make the cathode and the anode, तो उस केस में आप क्या देखेंगे कि these there is no change in the nature of the cathode rays which are being produced. मतलब क्या है कि whatever material of the electrode you take or whatever gas you take in the tube, the nature of the particles that are coming out as beam of electrons, they are all same in all the cases, right? Then the fourth one, that the velocity changes with applied voltage. If you vary the voltage, you can see a change in their velocity. They penetrate through the metal and other substances and also produce fluorescence. So they can enter or they can pierce through metals and they produce fluorescence. कैसे पता चला ये? Now in this discharge tube, there was a coating done on the other side, right here. And when these rays struck the glass here, see the diagram carefully. When these rays, after reaching the anode, when these rays struck this fluorescent screen, they produced a glow here. They produced a shine, a glow here. And so we came to know that certain rays were coming from the other end. अपने आप से तो they are not visible by naked eye. You can only detect them by the fluorescent screen. Okay. Then an obstacle placed in the path of cathode rays is heated up, and thus the cathode rays possess heating effect. They themselves, because they are fast moving electrons, they themselves, when they strike any metal plate, they can produce heat. The next point, cathode rays on striking solid objects of high melting point produce X-rays. ये एक important point है, and we'll come across it again when Roentgen discovered X-rays. So in his experiment, he concluded that cathode rays on striking solid objects of high melting point produce X-rays. Then they also affect the photographic plate. They can ionize the gases. Their E upon M ratio is constant. No cathode rays were produced when the tube was completely evacuated. Means if you remove the entire gas from the discharge tube, you do not see any kind of rays being produced, right? So no cathode rays were produced when the tube was completely evacuated. Then, like ordinary light, cathode rays come out at right angles to the surface of the cathode. They are perpendicular to this surface. This is your cathode. These are the rays that are coming out, and they are coming out at right angles and travel in a straight line normal to the cathode. So exactly straight lines is their path. They cast sharp shadows if opaque object is placed in their path. And lastly, if you place a small paddle in their path, एक छोटा सा फैन टाइप ये पैडल अगर आप इसके पाथ में रख दो, तो क्या देखेंगे? They show mechanical effect, that is, they have momentum and energy, and therefore they possess some mass. They are capable of rotating it. Okay, they show mechanical effect, and this proves that they have some momentum and energy, and that is they are containing certain mass. So these cathode rays are actually material particles. These are the basic properties of cathode rays that we come to know. Okay. Now, if we talk about this experiment, J.J. Thomson conducted this experiment, and apart from this experiment, what did he do? He calculated the E upon M ratio. He calculated the E upon M ratio of electrons, which came out to be somewhere 1.76 into 10 to the power 11 coulomb per kg. तो charge to mass ratio जब निकाला गया for the electrons. Now we know that these are beam of electrons, और यही इलेक्ट्रॉन्स जो हैं, अगर एक्चुअल में देखा जाए तो इनको नाम जो इलेक्ट्रॉन दिया गया है, that was not Thomson who named them electrons. It was an Irish physicist, George Johnson Stoney, who named these particles which were coming out of the cathode. He named these particles as electrons, right? तो इस तरीके से वी केम टू नो अबाउट द डिस्कवरी, वी केम टू नो अबाउट द इलेक्ट्रॉन्स, द एग्जिस्टेंस ऑफ इलेक्ट्रॉन्स, या ये कह सकते हैं कि इस तरीके से इलेक्ट्रॉन्स डिस्कवर हुए. Now, J.J. Thomson calculated the E upon M ratio and he found it out to be 1.76 into 10 to the power minus, 10 to the power 11 coulomb per kg. इसी से हम चार्ज ऑन पार्टिकल हमको मालूम ही है. देयर वाज एन एक्सपेरिमेंट व्हिच वाज कंडक्टेड बाय अ साइंटिस्ट कॉल्ड एज मिलिकन, R.A. Millikan. तो in his experiment he found out about the charge on the electron. और वैसे भी हमको पता है कि charge on electron is 1.6 into 10 to the power minus 19 coulomb. Now, if we know the charge on an electron and if we know the E upon M ratio of the electron, which was found out by Thomson, so can we find the mass of electron? It's quite simple. अगर हम दोनों को if we have to find the mass of electron, so what will it be equal to? We know the charge on electron, and if we divide it by the E upon M ratio, it gives us 1.6 into 10 to the power minus 19 coulomb upon 1.76 into 10 to the power 11 coulomb per kg. और अगर आप इसको डिवाइड करो तो इट कम्स आउट टू बी 9.1 into 10 to the power minus 31 kg. So this is the mass of an electron. Mass of an electron is 9.1 into 10 to the power minus 31 kg. Charge on an electron is 1.6 into 10 to the power minus 19 coulomb. And E upon M ratio of electron, please remember all these three. ये values आपको बार बार काम आएंगी in solving the numericals, so it's better to remember them. Okay, let's come to the next experiment which led to the discovery of the positively charged particles or the protons. तो ये पॉजिटिवली चार्ज पार्टिकल्स क्या थे, कैसे डिस्कवर किए गए, उसके बारे में थोड़ा सा देखते हैं. ओके, अच्छा, अगर हम एक जनरल प्रॉपर्टी देखें किसी भी एटम की, तो हमें ये पता है कि एटम इज इलेक्ट्रिकली न्यूट्रल. इनिशियली वी डू नॉट हैव एनी charged electron. All atoms are electrically neutral. Okay, तो electrically neutral कैसे है एटम? अगर एटम is consisting of electron, और इलेक्ट्रॉन पे तो अभी हमने निकाला कि इलेक्ट्रॉन consists of negative charge. अभी हमने चार्ज कैलकुलेट किया, इट वाज 1.6 into 10 to the power minus 19 coulomb. That much charge exists on an electron and it is negatively charged. तो कोई तो पॉजिटिव चार्ज एग्जिस्ट करता होगा एटम के अंदर, which will be neutralizing that negative charge. Only then it is possible to have a neutral atom. Okay, तो इसी के लिए let's place the heading here, discovery of proton. Let's see how the discovery of proton took place. Okay, so in 1836 there was a scientist named as E. Goldstein. Okay, he discovered that this experiment is basically the same as the cathode ray experiment which J.J. Thomson conducted. उसी में थोड़े से modification किए गोल्डस्टीन ने. Okay, what did he do? That he made a perforated cathode. अगर आपने प्रीवियस एक्सपेरिमेंट आपको याद हो तो वहां पर हमने सिंपली एक कैथोड लिया था. यहाँ पर हम एक परफोरेटेड कैथोड ले रहे हैं. परफोरेटेड मींस विच इज हैविंग पोर्स इन इट, विच इज हैविंग होल्स इन इट, जिसमें से कि कुछ पास हो सके. ओके, परफोरेटेड मटेरियल. So he took a perforated cathode in this experiment, and what did he do? He connected, there was a cathode, there was an anode, and both of them were in the same manner connected across a high voltage battery. Okay, same as the previous experiment, the pressure inside the tube was very low. तो अब क्या देखा गया कि इन एडिशन टू दीज कैथोड रेस, जब हमने एक्सपेरिमेंट कंडक्ट किया तो वी सॉ द मूवमेंट ऑफ सर्टेन रेस फ्रॉम द कैथोड टुवर्ड्स द एनोड. Now Goldstein observed, because he has made this cathode as perforated cathode, he observed that there was some other rays, some other new kind of rays which were streaming behind this cathode. Okay, which were moving behind this cathode. Look at the diagram carefully. This is your perforated cathode, and what did Goldstein observe in the experiment? That if this cathode was perforated, if there were pores or spaces inside, it was observed that there was stream of rays going behind the cathode also. तो ये rays कहाँ से आई? This is the next question that should come to your mind. Okay, in actual what is happening here, if you see that these rays are traveling in opposite direction to the cathode rays. Cathode rays were moving in forward direction, these rays are moving in backward direction. मतलब क्या है कि ये rays कहाँ से आ रही होंगी कि जो पॉजिटिवली चार्ज्ड प्लेट आपने ली, जो एनोड आपने लिया, डेफिनेटली दीज रेज आर कमिंग फ्रॉम दिस एनोड. ओके, तो ये हमें किस तरीके से पता चला कि ये एनोड रेज का नेचर क्या है, इनकी कैरेक्टरिस्टिक क्या है, थोड़ा सा ये भी देखते हैं. जैसे ये कैथोड रेज वर ट्रैवलिंग इन स्ट्रेट लाइन पाथ, सिमिलरली यू कैन सी दीज एनोड रेज आर आल्सो ट्रैवलिंग इन स्ट्रेट लाइन पाथ. Correct? They are also perpendicular to the cathode plate which we have taken. Now these anode rays, if you see the same thing, if you do with these anode rays, if you place a charged plate in their path, एक positively charged plate और एक negatively charged plate इनके path में लगाओ, तो आप क्या देखोगे कि these rays will be deflected towards the negatively charged plate. और अगर ये negatively charged plate की तरफ deflect हो रही है, तो इससे हमें क्या पता चल रहा है कि these rays are positive in nature. They are made up of some positively charged particle. Then only they can get deflected towards the negative plate, right? One more thing, if just like the cathode ray in the cathode ray experiment, these rays are also capable of rotating a wheel. If you place a wheel in their path, they are capable enough of rotating a wheel placed in their path. They are also capable of producing heating effect, as you had seen in the case of cathode rays. Okay, and the charge to mass ratio of these rays, E upon M ratio, if we see, it is very small. It is considerably small as compared to that of electron. E upon ratio of these rays is very small as compared to that of electrons. One difference, that unlike the cathode rays, E upon ratio of these rays depends on the nature of the gas taken in the tube, right? वहां पर हमने क्या देखा था, यू रिप्लेस एनी अमाउंट ऑफ गैसेस, कोई भी गैस आप डिस्चार्ज ट्यूब में ले लो, कोई भी वेराइटी ऑफ इलेक्ट्रोड आप डिस्चार्ज ट्यूब में ले लो, in all cases those particles were the same. But here what we are observing is that as we change the gas in the tube, we are finding different E upon M ratio. Okay, E upon M ratio of these positive rays depends on the nature of the gas taken in the tube. So these are certain properties of the anode rays which were discovered by Goldstein in his experiment. So this is how we came to know about the positively charged particle or the proton, because these positively charged rays are made up of positively charged particle which we call as the proton. अगर मास की बात करें तो पहले चार्ज देखते हैं. चार्ज ऑन प्रोटॉन इज हाउ मच, 1.6 into 10 to the power minus 19 coulomb. And E upon M ratio of if we talk about hydrogen gas placed in this discharge tube, then E upon M ratio comes out to be 9.58 into 10 to the power 7 coulomb per kg. So can we find the mass now? Just divide the charge by E upon m ratio. This becomes 1.6 into 10 to the power minus 19 upon these many coulomb upon 9.58 into 10 to the power 7 coulomb per kg. और अगर आप इसे सॉल्व करो तो दिस कम्स आउट टू बी 1.67 into 10 to the power minus 27 kg. जबकि अगर आप को याद हो तो mass of electron that we found out, mass of electron was how much? 9.1 into 10 to the power minus 31 kg. So we can say that proton is a subatomic particle which carries 1 unit positive charge. What do we say? 1 unit positive charge. And the charge, 1 unit positive charge means how much? 1.6 into 10 to the power minus 19 coulomb, and it is having a mass of 1.67 into 10 to the power minus 27 kg. Okay,